Okay, so I've got the sum formulas for sine and cosine written down up here. What I want to do is use these to derive the difference formulas for sine and cosine. So we'll do sine together, and then I'll have you pause the video and work out the one for cosine. Okay. So if I wanted to look at sine of a minus b, okay, there's a formula for that as well, but I don't really need to memorize a whole new formula because I can just say that's sine of a plus the opposite of b. So I can rewrite subtraction as just addition of the opposite. And so now I'm going to just plug this in to the sum formula for sine. Instead of plugging in b, I'm replacing all the b's with a negative b. So I'm going to get sine a cosine negative b plus cosine a sine of negative b. And then I can simplify things even further because I can remember that cosine is an even function. So since cosine is even, remember that means that cosine of negative b is the same as cosine of b. Opposite input gives me the same output. And sine, I want to remember, is odd, so that means that sine of the opposite of b is the opposite of sine b. Opposite input, opposite output. So I can say this is just sine a. Cosine of the opposite of b is just the same as cosine of b. Now here, this is going to become the opposite of sine b, so I'm going to introduce a negative sign in the front. I'm just going to bump that to the very front of the term, and it becomes minus cosine a times sine b. So notice, all that really happened is just the sign in between the two terms changed. Okay? So you can either just sort of remember that trick, or you can derive it by rewriting subtraction as addition of the opposite, and then using the fact that cosine is even and sine is odd. Okay. So I'm going to suggest that you pause the video and derive the difference formula for cosine. So do exactly what we just did for sine. You're going to start with cosine of a minus b. Rewrite that as adding the opposite. Use the fact that sine is even, that cosine is even, and sine is odd, and simplify that formula. So go ahead and pause the video and do that. Welcome back. So if we do this, we get cosine of a plus the opposite of b. And plugging that in is cosine of a, cosine of the opposite of b, minus sine of a, sine of the opposite of b. Again, cosine is even, so this just becomes cosine of a, cosine of b. That negative sign just drops out. Here, sine of negative b is the opposite of sine of b, so I'm introducing a negative. That'll cancel with this negative, and it just becomes sine a, sine b. Okay, kind of cool. Okay. Notice with cosine also, all that happened was that the sign in between the two terms got changed. Okay. Now, I can use these difference formulas that we've just derived to prove some nice cofunction identities. So cofunctions, all the trig functions come with a partner. So sine comes with cosine, tangent comes with cotangent, secant comes with cosecant. Okay. And I know that cosine of theta is the same thing as sine of pi over 2 minus theta. I know that that's true at least if theta is an acute angle. Because if theta is an acute angle, then I would have, if theta is here, then these two acute angles in a right triangle would have to be complementary angles. That's what the co in cosine and cotangent and cosecant stands for. Okay. So if I were to take a look at cosine of theta, that's this side. I'm just going to label them A, B, and C. Cosine of theta is, in this case, A over C, but sine of pi over 2 minus theta, well, That's also A over C, because what's adjacent to this angle is opposite that one. Now what's neat is I know that that's true if theta is an acute angle by just using my right triangle trigonometry. I can now use the difference formula to prove that this is true all the time. If I take a look at the right-hand side, because the left-hand side is kind of as simple as it's going to get, if I take a look at that right-hand side, you can say, okay, that's sine pi over 2 minus theta. So now I'm just going to use the difference formula for sine. And remember what we saw is that it's essentially the sum formula, but with that sign replaced with a negative sign. So I can say that's going to be sine of pi over 2 times cosine of theta minus cosine of pi over 2 times sine of theta. So the two angles that I'm subtracting are pi over 2 and theta, okay? And so I plug this in. Now sine of pi over 2 is just 1, and cosine of pi over 2 is just 0. So I get 1 copy of cosine theta minus 0 copies of sine theta, and that's just cosine theta. Okay. And there are 5 other identities similar to this. Turns out sine of theta is the same as cosine of pi over 2 minus theta. And then I can do the same thing with tangent and cotangent, and secant and cosecant. What I'm going to have you do is just pause the video, just prove this one. Use the difference formula for cosine to prove this one. And all the other proofs are very, very similar. We haven't actually talked yet about the sum and difference formulas for tangents and things, but we're going to do that in the next video. And if I had secant, I would just write it as 1 over cosine, and then I can use the formulas for cosine for that. Okay. But go ahead and prove this one. Pause the video, prove this one, come back in a moment. Welcome back. Okay. So, if I'm looking at cosine of pi over 2 minus theta, so I'm going to try to prove this. I'm going to start with that right-hand side, try to simplify till I arrive at the left-hand side. Okay. So my right-hand side was cosine of pi over 2 minus theta. The difference formula for cosine, here I'm using pi over 2 and theta, and I'm just going to replace that with a plus sign. That's the shortcut. Okay. So I can say this is cosine of pi over 2 cosine of theta plus sine of pi over 2 sine of theta. But cosine of pi over 2 is 0, and sine of pi over 2 is 1. So I get 0 copies of cosine theta plus 1 copy of sine theta, and that's just sine theta. So we're able to prove that cofunction identity as well. We don't yet have the tools for working with tangents and cotangents. We're going to develop those in the next video, get some formulas for those. Although you can sort of see how we can get those, because tangent I know is just sine over cosine. So if I've got formulas for sine and cosine, I can use those to build formulas for tangent, and that's what we'll look at in our next video.